Okay, let's start with the first 3D object, which is called as cuboid. And let's see what is a cuboid. In its simplest definition, we have seen cuboid every day. We use it in everyday life, whether it's a brick or an Amazon shipping box or a matchbox or a shoe box or even a notebook. It's a cuboid. And what is a cuboid? It's a 3D object. That means it has got three dimensions, X, Y, and Z. If you see here, this rectangular box, this is the X-axis, this is the Y-axis, and this is a Z-axis, right? This Y and this X, okay? So a 3D object which has got 6 faces and all are rectangular in shape and all the angles are right angles. So what does it mean? If you see this shape in yellow, this is rectangular in shape, and we know that for all the rectangles, those two edges always meet at 90 degrees. We know that. And it has got 6 faces, because if you see this rectangular box, or even if you take a brick, there'll be top and the bottom, 2 on the side and 2 on the front and back. If you see the Amazon box, you will know that. And another way of looking at that is, once you open up this Amazon box or even this rectangular box or even this brick, if you just completely open it, unfold it, this is how it will look like. And see the way it is folded. You will see this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6 faces. Okay, and the way you see it, once it's folded, this is how it looks like. So once you fold it, the black goes to the bottom, the top, this is the top, the black is the bottom, and the blue and the green are the sides, if you see here, and this is up front, and this is the what is left, yeah, this is the back, yellow is back, black is the back. Okay, this is how it's structured. Did I put it right? Yeah, that's how it's structured. So that's all is a cuboid. Okay, all you need to remember is 6 faces, all are rectangular in shape and always they're in 90 degrees. On the rectangular side, this is called as the length, this is called as the height. Okay, length, height, and this is called as the depth, or you can also call it as a breadth. And a lot of textbooks use this interchangeably. Length is the longest one, but height, depth, breadth are used interchangeably. It does not matter. You just need to remember that there are 3 dimensions based on how you look at that. Okay. Now there are 2 importance, and there are good references here if you want to get more images. I have copied some of the images from this site, so it's good extra reading, but I don't think you need that. Okay, there are 2 important dimensions that we need to know for each of these 3D objects. One is the volume and one is the surface area. Let's figure out the volume. What is volume in simple definition? If you take this box, when you say volume, how much space this box has inside. If you're going to store a water in this, or if you're going to store some books or apples or anything, vegetables, how much volume this can carry. Normally in the two dimensional this thing, it's a surface area, but in this case there's a volume. So how much volume it carries. And to think about that, what you can think is, this box here is nothing but a stacked up rectangular sheets. For example, if you just take a rectangular sheet like this, or a rectangular shape which is 2D in image, like a ABCD, and if you keep on stacking up images like books like this, let's say if you're going to keep on one book, book 1, and then pile up all the books one above the other, right? Pile up books one above the other. This is how it will look like. Okay, so automatically you're converting from a 2D to a 3D perspective. Okay, and then this is how it looks like. And then if you just remove these grid lines, this is how the box looks like. So you can think about the volume as stacked up rectangular sheets one above the other vertically, and wherever you stop, that becomes the volume of that. And in that case, this is the length, this is the breadth, because this is the length here for a rectangular, and we know there's a breadth here for a rectangular because it's a 2D. But when you keep on stacking up, then when you stop the stacking, whatever you get in the 3rd dimension, right, it's the height. Okay, so length, breadth, and height. Like I said, over here if you see, they must have used height, length, and depth differently, but don't worry about that. There are 3 dimensions. There's a length and breadth that we know from rectangular, and since we are stacking it up, there is a height. So once you get that, if you talk about the volume and how much it stores, basically if you assume that if you're going to keep on piling up some apples in this, right, if it's a rectangular box, let's say you got 4 apples, you piled up like that, okay, or you placed it. But if you're going to stack up the rectangular sheets, each apple is going to have an apple over that till the height of this. Okay, so the number of apples will be computed based on the length, the breadth, and the height, because you're stacking up. So the length into the breadth into the height, that means For a cuboid, you take all the three dimensions, height, length and breadth, and multiply that. That will give you the volume, which is nothing but the space, how much space the box has inside, and based on what you're storing, that's the space you can store. And in any of the mensuration problems, always make sure that you attach the number of units. If the given length and breadth and dimensions are in centimeter, since you're multiplying three dimensions together, so it's like centimeter multiplied by centimeter multiplied by centimeter. This is called a centimeter cube, or you can call it cubic centimeter. That's the volume in the unit. Like in area you have in meters, square meters, you have it in volume, square centimeter, sorry. That's how you structure. So always you need to put the unit of measurement. If it's not given, then you just simply say cubic units or units cube. You can also say like unit cube. Okay, you can like that. So make sure that this part is important. Okay, and that's the volume of a cuboid. And I don't think you need to really memorize that. If you just, because I want you to reduce the memorization, because there are a lot of formulas, so you'll forget one by one. So as long as possible, whichever is easy, don't memorize that. So volume of a cuboid, multiply the three dimension. That's it. Okay. Now let's move on. Now there's some concept is called, for all the 3D objects and even 2D objects, there's some concept called as surface area, which is pretty much area since it's a rectangular over here. If you see here, let me erase it. If you see a rectangle. So in the 2D world, there's a 2D world because there is no 3 dimensions. It's a 2D world. So in 2D world, you have just the length and the breadth, right? You just have the length and the breadth, and the area is given by length into breadth in the 2D world. Okay. But in the 3D world, where we have this height also, so how do we compute the surface area of that? And there are two types of surface area that we're going to talk about. Okay, one is the total surface area. For example, we know that this box, okay, this box has got 6 rectangular faces. Okay, we have seen that. And where have we seen this? We have seen it over here. If you remember, this was a diagram. There are 6 faces and all of them are rectangular. In this case, it's a cube, but assume that it's a rectangle. Assume that it's a rectangular shape. Okay, so there are 6 faces, right? Over here also, if you see 2 top and bottom, they'll have the same area, 2 on the side and 1 on the front and the back. There are 6 faces. Okay, so if you're going to add up all the area of one rectangle will be given by the 2 dimensions, length and breadth. Similarly, if you find the area of all the surfaces, right? If you find the area of all the surfaces and add them up, that is the individual area of all the 6 surfaces, and add them up, that is called as total surface area. It's a total surface, all inclusive. Okay. And there's another concept called as lateral surface area. And what does it mean? Let's say if you don't count the area of the top and the bottom, only the lateral. Lateral means sides. Yeah, the dictionary definition of lateral is sides. Okay, on the sides, whatever is on the sides. So there are only 4 sides. If you exclude the top and the bottom, there are only 4 sides. So instead of taking and adding up the 6 individual rectangular faces, if you just count the 4 sides which are on the side and add them up, that's called as lateral surface area, or LSA. That's what's written here. Okay, and there's a simple concept that you need to remember. Total surface area, which is called as TSA, it includes all the 6 sides. Lateral surface area will exclude top and bottom. Do not include top and bottom. Include only lateral surfaces, which means only the sides, and there is nothing but 4 sides. That's how it is. Okay, now how do we compute each of these areas? Let's take the total surface area, which is all the 6 sides. Now we know it's all rectangular in shape, so obviously the top and the bottom are going to be having the same area because it's similar in dimensions. Similarly, the front and back will have the same dimensions, and the 2 on the side will have same dimensions. Okay, so out of the 6, it's a pair of 3 pairs. 2 will be having the same dimensions. So what does it mean? Total surface area of the cuboid is equal to total area of all the 6 sides or surfaces, and all the 6 sides and surfaces are rectangular in shape. And the way we'll count is area of the top plus area of the bottom, because there are 2 of them and they have the same dimensions. Area of the left side and the right side, again we'll add them up, and the area of the front and back. So it's a 2 surface here, 2 surface here, 2 surface here, and if you add them up, it gives you the 6 sides and the 6 surface. Okay, and now let's compute the area of each of the section. Okay, depends upon how you count that. Let's take this diagram. Okay, let's take this diagram. And let me erase everything else. Okay, let me take this diagram. So if you see let's take this rectangle at the bottom. Okay, bottom and top are going to be the same. So if I take the bottom and top, so let's say I call this length and this I call this breadth. Okay, length and breadth. Okay, that's how it. And then you stack up the sheets on this. Okay, pile up, stack. But the bottom, it's going to be length and breadth. The area is going to be only 2 dimensions. But we have got 2 of them on the top and bottom, which will have the length and breadth. So we do twice. So area of the top is going to be length and breadth, and area of the bottom is also going to be length and breadth, and that's how we add it. Similarly on the sides, okay, once you do this volume, and if you take this side, for example, let's say I'm taking on the right side. The right side is 1 dimension is breadth and 1 dimension is height. So there is no length here. So we are going to multiply breadth and height to get the area of this rectangle that I am highlighting. And the same thing I'll duplicate on the other side, on the left side also, right? So breadth into height will be the area of the sides. Okay, so what I've done is area of the left and the right side, breadth into height and breadth into height. I'm adding it twice. And now let's check out. So we have covered the top and bottom, we have covered the left and right side. Let's cover the front and the back. Front is what is facing you, this section, right? This section. And similarly we'll have an exact dimension rectangle on the back also. So let's assume, or let's calculate the dimension of what we can see. So there is a length here. Okay, there's a length here, and there's a height here, because we're talking about this rectangle. Okay, over here. Okay, so there's a height and there's a length, and we have to do it twice, because there is going to be a rectangular face surface side on the back also. So length and height will come twice. Okay, the length and height, which is the front and the back, will come twice. So you have to just add them up. So this is like 2lb, then this is like 2bh base into height, and this is like 2 length into height. So basically what you have done is the total surface area is twice. Within the brackets, you take all the 3 dimensions and make different permutations and combinations of that. Length into breadth once, then breadth into height, and length into height. And we have to double it because there are 2 sides, or there are 3 pairs with equal dimensions. So twice within the bracket, the different permutations and combination. Length into breadth, breadth into height, and length into height. And last but not the least, we should not forget this is the area, so it's going to be square units. If it's centimeter, then you say centimeter square, or square centimeter, it's the same thing. If it's a meter, you say meter square, or you can say square meters. If there are no units given, you just simply say units. This is very important. Okay, don't forget. In the above case, in the volume, it's cubic because there are 3 dimensions. Okay, now let's come to the last section where we talk about lateral surface area. What is lateral surface area? Like I said, exclude the top and the bottom, include only the sides. So in this, the top and the bottom is this piece. So you completely exclude this piece. Okay, you exclude this. So whatever is remaining, we already seen, it's just this piece. Okay, this piece and this piece and this piece and this piece. So if you just take that, it's what you get, right? So you're excluding the top and the bottom. So the 2 sides are gone. So now it has gone only 4 sides. There are 2 sides here, and plus there are 2 sides here, and that matches to the 4 sides. Okay, and you just copy those things, and whatever you get in the reduced dimension of lateral surface area, it will be again twice, because the 2 sides are repeating, and the dimensions of individual them are the breadth and the height, and plus length and the height. So excluding the top and bottom, whatever is the top and bottom, if you assume that this is the bottom, so the length and breadth will go away. So based on how they ask in the exam, just figure out what is the top, what is the bottom. Don't worry about what is length, what is breadth, and what is height, because this can keep rotating. Just focus on how have they given the dimensions, and think about top and bottom, 2 sides, and front and back, and based on that you calculate. Lateral means no top and no bottom. Okay, and total surface area means all the 6 sides, sorry. So that's how those are 3 dimensions. In all the 3D objects, you will see this is the same format that we are repeating, where we calculate the volume, and then we calculate the total surface area and lateral surface area. And as long as you understand this formula and can imagine, this takes a bit of visualization. Once you imagine the boxes and the shape, it's very easy. And that's then I've given examples of what a cuboid is, like I said, a shoe box or a brick and stuff like that. And that's how I'm going to structure each of the episode based on the shape, so that based on the shape you can remember as much as possible what would be the dimensions and the formula for that, and how you should think about that. Because a lot of exam problems will need some kind of imagination on how it is structured, and you might have to visualize it. So it's better you start visualizing from the get-go. Okay, I'll see you in the next episode.